Hey all you cool cats and kittens. If you know what I just said, I know what you've been up to during self-isolation. But it's Miss Fleming, otherwise Jody, here to give you your second little math lesson. This one I would suggest watching on your own as a parent. There might be clips that you want to do with your child later on, but it's a lot of key information about quantity, what that means, and kind of what to look for when you're working with your child. I used the term diagnostic at one point in the video, and I just want to make that clear that a diagnostic is actually like a little test or a quiz that you give to your child or to your spouse or whoever you want to, and that is for you. That's for you to learn what your child knows, what they understand, and maybe where the gaps are in their learning, and then you use that diagnostic information to then use it as a teaching point or a leaping point. So you know kind of what to target when you're working with your child. So there's a lot of diagnostic ideas and activities in today's lesson. So I really would encourage you to try out a few little experiments with your children, and then use what you learn in order to narrow in on an area of focus for your math learning. All right, so here we go. Oh, and I have a little bit of a better setup today. Staples is still delivering, so I was able to get some chart paper and some amazing Mr. Sketch. You all know what those are. And I promise I didn't have too many markers before I started this. All right, so good luck, have fun, and you'll see me again at the end of the video. Okay, so today's lesson is on frequent, meaningful experiences with numbers. And you can see I've highlighted the word frequent and the word meaningful because those are our key players. As adults, we see our children, we see how smart they are, we see how quick they are to pick up things in the real world. And then we sit down for school time, and we're actually surprised at how much they forget when you've seen them day by day show you actually how much they really do know and how much they do understand numbers. So that's kind of hitting on this part right here, meaningful. Kids are really smart, and when the learning is presented to them in a really meaningful way, they remember. As adults, we've had our whole lives to practice with numbers, to have lots of experiences, quantifying things, and really trusting and knowing how much numbers are worth. So that's kind of what I want to focus on today is what numbers really are, as in quantities, and how much experience we really do need with those numbers in order to be able to trust. So I'm going to write that word down, trust. Okay, so next I'm going to show you what I mean by trust. And first what I want to do is I just actually want to circle the word numbers. And I want to talk about the phrase quantities. Numbers are a quantity. And I'm going to also write down quantity is a representation of how muchness. So how much is a number actually worth? And oftentimes I see kids who are struggling in math or have low self-confidence in math. It's not because they're not capable, it's because they're struggling to trust how much a number is actually worth. So for example, and you guys have probably all seen this before, I'm just going to get some counters out here. If I were to show you this quantity or your child this quantity, they might be able to look at that right away and recognize it and say 5, no problem. And actually you probably look at that too and think, oh, that's familiar. It's the same way that dots are arranged on a number die. And so I've seen 5 a lot. I play board games. I have lots of experience seeing the number 5 in this arrangement. I have frequent experiences seeing this. So I'm able to trust that that's 5. But what will sometimes happen is then I mix these up and I show the dots in an arrangement that is not as familiar for your child. And instead of looking at that and saying, oh, that's 5, they actually have to count them. 1, 2, 3, 4, 5 to tell you that there's 5 there. You may have even had to do it as an adult, okay? So what I would encourage you to do, just to do a few little experiments with your children at home to see whether or not they're able to trust certain quantities of numbers, is to get some counters out. These are crokinole pieces that I had from a board game. I'm struggling with finding counters in my house, but anything will do. If you've got coins, macaroni, small blocks, whatever works for you, is to put out some numbers and have your child count to see how many there actually are. First of all, I want you to notice whether or not they recognize a certain number to begin with. So how do they count? Do they point to them? 1, 2, 3, 4, 5, 6, 7, 8, and count them 1 to 1. There's a lot going on even just with that. When I point to them and slide them to a new position as I count, that's showing 1-to-1 correspondence. So maybe you put out the 8 counters and your child loses count. 1, 2, 3, 4, 5, 6. All right. Oftentimes you'll notice that, especially with really young children. And the key is to go back to the numbers that they actually were able to count correctly with a 1-to-1 correspondence. 1, 2, 3, 4. And then maybe just do some exercises working with 4. Try 4 in a few different arrangements. Have them cover their eyes. You can rearrange them into new positions, maybe a familiar arrangement like on a die, and then try in some other arrangements. Spread them out a little bit. When they open their eyes, are they able to look at that and see 4 and shout out 4, or do they have to count them all over again? 1, 2, 3, 4. Close their eyes, rearrange them again, have them open their eyes. Do they recognize that it's still 4, or do they have to go back and count again? If they're having to go back and count time and time again that quantity of 4, then they need more meaningful and more frequent experiences with that quantity. Not just the numeral 4 written out, but with the actual quantity. Okay. Another fun game that you can do is to actually see if they will hold on to that number. So that was 1-to-1 correspondence counting. But if I said I'm going to add a few more counters, do they actually have to then go back to the beginning and count 1, 2, 3, 4, 5, 6 in order to give you the new total? Or are they able to remember that I already had 4, so now I can count on 4, 5, 6? That's a next level skill. And you'll probably see kids doing this all of the time with their fingers, having to go back and count 1, 2, 3, 4, 5, 6, 7, but knowing that they have 5 fingers. It can seem really, really frustrating, but if they're having to go back and count the fingers on their hand every single time they're doing a counting activity or number activity, that tells you that they don't trust the number 5 and how much it actually is. They need more experiences with that number and with that quantity. So a fun little game you can do in order to help with counting on and trying to trust and remember the count is to actually cover up some of the objects that have already been counted and to have the new ones that have been added on the outside. So they have to remember how many objects are in the cup and then count on. I think there were 4, 5, 6 in order to get my full count. And when I take them off, do I have to recheck by counting individually, or can I trust that this is 4 and I've added 2 more to make 6? Once I've got 6, I'm going to add a few more. Do I remember how many are in the cup? 6, 7, 8, 9. And you can play games like this over and over again because, again, they need lots of experience with it. But then you'll also want to start to notice, now do they recognize a quantity that's sitting outside of the cup without having to count them individually? I see that as 3. I trust it's 3. I have lots of experience with 3, thankfully. So I remember that I've got 6 in the cup, and there's 3 out here, and 6 and 3 go together to make 9. All right? Okay, so the next point I want to make is in reference to benchmarks. Benchmark is a term that we use in order to refer to numbers or quantities that are really familiar to us, numbers that we know and numbers that we trust. So 5 and 10 are the 2 benchmarks that I've written down to start with, mostly because 10 is the basis of our number system. We've got a base 10 number system, and surprise, surprise, it has to do with the fact that we've got 10 fingers. So very early on, we learned that counting with our fingers, and our fingers are a fabulous tool to be used in helping us with mathematics. So I've broken that then into half. So we've got our 5. So as some of the activities I showed you earlier started with a much smaller quantity. We want our young guys working with the number 5 as much as they can to help them gain experience and trust with that number. So then we can use it and we can start working with 10. So the counters here I have laid out, 5 white, 5 black. Is really important. It's a visual representation of that 10 and showing that 10 split in half. So the more that we can show 5 and 5 with 2 different colors or 2 sets of objects helps our kids learn to trust. So I can look at this now that I've got many experiences and see that that's 5 white and know it's 5 white, and then I can count on. So I can start adding quantities like 5 and 2, 5, 6, 7, 5 and 4, 5, 6, 7, 8, 9, and I know I can double 5 now too to make 10. Seeing 5s in our everyday environment helps us gain those experiences. I don't know if that's in focus or not. Maybe I'll slide this down here. There we go. There's my 5, and if I have 2 equal rows of 5, then I can start to learn that doubling my 5s is counting by 5s, but I don't have to now go back and count the black, because if I know that there's 5 in this row and this row is identical, then I can trust that I've got 2 rows of 5 and 5 is 10. Once you're confident working with 5s, then we move on to groups of 10, and you guys would have done this too. Maybe it's when you're counting coins at home. You've got your 10 dimes set out, and you know you've got a whole dollar. And now I can start to add on. So I can see very clearly, I trust that I've got 10 here and 2 more. So now using my counting on strategies, I can say for sure this is 10, 11, 12. So trust in those benchmarks, 5 and 10, is crucial for then being able to go on and build bigger numbers later on. For some of our kids that are older, we can now start to assign quantities that are beyond 1. So if I can trust in my mind that this 1 counter is worth 10 and I have 10 10s, I'm now working with 100. 110, 120. So you can see how the patterns start to emerge. This isn't just primary based. We need to have lots of experiences with 5 and 10 to then transfer it to working with halves and wholes later on. So if you could see my decimal, there we've got half, 5 tenths, and 1 whole later on. So this here, although you may be thinking, oh, this isn't for my kid, it is. If they don't have a strong understanding of 5 and 10 and how that works in our number system, they're not going to feel confident working with larger quantities later on. Okay, we're going to do a little experiment here, or an activity. So underneath the fabric, I have some counters laid out. In a second, I'm going to lift the fabric up. I'm going to give you a chance to take a guess as to how many counters you see. Perhaps you're really fast and you'll be able to count them in the amount of time that I give you. All right, are you ready? Okay, so you've got a number in your head, and I want you to think about how confident you are in that number. So maybe you're a really fast counter, or perhaps when you saw those you recognized that I had 2 different colors. So right now in your mind you're going, I know for sure that I saw 2 white, or was it 2 black, and a whole bunch of the opposite color. Perhaps you used what you knew about those 2 to then help you count the other objects, or to give you a rough idea of how many you think are there. So if in your mind you're thinking, okay, there's anywhere between 6 and 8 counters, or maybe 10 counters, I would say that that's a reasonable guess. All right, and of course I'm going to give you the chance to see how many there actually are. So while you're counting them, I'm going to write down the word reasonable. And if you've been in my class before, or if you have had a child in my class, perhaps You've heard this word in excess at home, but I use it all the time, reasonable. Reasonableness is a really good indicator of our understanding of a quantity. So if you had a reasonable estimate, and I said anywhere between 6 and 10 would have been reasonable, then I know that you have lots of familiarity working with this type of quantity. So as you can see, we've got 2, 4, 6, and one more to make 7 counters. So 7 was a reasonable guess. You'll notice that when I went to move those counters and count them myself, I went to the 2 white right away because I could trust that there were 2. The next thing that I saw were these 2, and the 1 additional. So I was counting by 2s, and my understanding and confidence with 2 in order to help count that quantity. 2, 4, 6, and 7. All right? Maybe some of you saw it in a different way. Maybe you saw the 2 groups, I think it was kind of like this. You saw the 2 groups of blacks, like this, and the 1 outlier. Perhaps you actually were able to trust that there were 4 on the top and then 3 additional on the bottom. How you see those numbers is going to differ based on each individual and your experience with the different quantities. So games like this are a lot of fun. So I'm going to actually cover them up again and stop this. Okay, I'm back with a new quantity. What you're going to do now is kind of take some of the strategies that I showed you before to make a reasonable estimate. Look at the colors. What numbers do you see that you know and that you trust, and how do you count on? Okay, are you ready? All right. Go ahead, hold on to your guess, and let's see if what you were able to come up with was reasonable. All right, we've got, I look at this, I see the 5 right away that I know and trust. I see another group of 5 up here, 2, 2, and 1. I trust that combination to be 5, knowing I've got 10, and the 2 outliers to make 12. All right, perhaps you saw it a different way. I'd be really curious to know how your children did with this activity, and you might be surprised too. If you see that they're starting to fail, that their guesses are becoming unreasonable, that tells you they do not have frequent, meaningful experiences with quantities beyond probably the 5 or the 10. All right, so let's do one more. Okay, I've got a new quantity for you underneath the bag. I'm going to give you 3 seconds, just like the other ones, for you to make a reasonable guess. All right, I'm hoping that you found that one challenging. And the reason for that is now I've got a significant number of counters more than what we were working with before. So you might be able to know and trust that the last one was 12 and come up with a reasonable estimate based on how much you know 12 looked like and what the new arrangement is looking like. But it becomes a lot difficult the bigger that we get, or sorry, the higher the quantity that we have. For myself, I actually have to count these 2. Looking at this, I'm not seeing a confident arrangement that I feel good about. So I might then resort to counting these with a 1-to-1 correspondence or a 2-to-2 correspondence. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and help figure this out. A lot of our children will look at this and then go right back to counting 1 by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, etc. Even as adults, when we're faced with quantities that are a lot larger, we start to resort back to the 1-to-1 correspondence and counting by 1 because it's the only thing that we feel confident with at that time. Some of you are probably at home with all your kids giving a head count and you resort back to counting by 1s. Or I can't even think, you're dividing up a Skittle bag and you go back to counting by 1s. Why count by 1s if we know that we are confident in our benchmark numbers? Counting by 5s, counting by making groups of 10. There's 5, 10, and 2 to make 12, 5, 10, and the 2 extra. So now I've got them into groups. I can group them into groups of 10, 10, 20, 24. The more activities you can do like this, the better off your children are going to be. And actually, you might start to recognize too where your weaknesses are with your estimating. Okay, so the last thing I'm going to talk to you about today is a little bit more about reasonable estimates. So I already talked to you about the reasonableness of something, but estimate is the key word here in the sense that an estimation will actually tell us a child's understanding of how much a number is. So what is their sense of magnitude? How big is a number or a quantity? We can get to their underlying understanding by having them estimate. So I will often do little tasks in my classroom, little diagnostic tests with kids and have them estimate, and it gives me a really clear picture about the quantities that these children know and understand. So we've probably all experienced this before. I might lay out a few counters and say, how many do you think are there? Cover them up just like we just did. And if they give me a reasonable answer, anywhere between 3 and 6, I would say for a young child is fairly reasonable. Some of them might know and trust that it's 5 already, no problem. That tells me that they have a fairly good understanding of that quantity 5. Then, in my next breath, I put out just a handful more counters, have them take a quick look, cover them up, and sometimes you'll have the child say 100. Going from this being 5 to this being their guess of 100 is a major red flag. This tells me that they really have no idea or understanding of how much this quantity actually is. Our reasonable guess without counting them here would have been about 10 or 11. So if my child goes from guessing 5 relatively accurately to then saying 100, that tells me that the understanding has fallen apart. So I need to then go back and pinpoint what quantities do they know and trust, where does it start to fall apart? Perhaps it falls apart at the number 7. This goes the same for older kids. You might be able to say to them, okay, we're gonna do homework you've got half an hour before we do homework, 30 minutes, and that they understand that a half an hour is gonna be about the length of one TV show. So that's a benchmark, TV show, 30 minutes, that they're familiar with. But then when you say we're gonna do homework in 2 hours, or you've only got 2 hours, then you have to clean up your room, and they tell you that 2 hours is 1,000 minutes, or that you would be able to watch 4 movies in 2 hours, the understanding falls apart. So doing guessing games and activities that involve estimating at home are amazing. This adds to that frequent, meaningful experiences with numbers that helps them build up their understanding of certain quantities. I hope that makes sense for you, and I'll probably touch base on estimating and what that means for our understanding of magnitude in one of my other lessons. All right? All right. I know that today's lesson was long, but hopefully it was informative. Frequent, meaningful experiences with numbers is how we build our understanding of those numbers and those quantities. We need to have all kinds of experiences estimating and working with quantities in order to retain that information so that we can use it later on. You'll notice that I didn't post any websites or any worksheets because what I want you to do in the coming weeks, days, years, it should be a regular habit, is to just estimate. Look at the numbers that are around you on a daily basis and play with them. You're going for a family drive and you see that the speed limit is 80 kilometers per hour. What can you use about going 80 kilometers an hour? What can you use about that in order to predict what 100 kilometers per hour would be like, or 50 kilometers per hour? Visualize what it would be like and how much of a distance, how much space 10 homes in a row would take up versus 100. When you're scooping out dinner tonight, estimate how many bites it would take in order to get through that macaroni and cheese. Or you're pouring your wine glass. How empty, how full. Estimating is everywhere that you look. Your kids might be sick of you by the time you're done because it requires them to think every time they ask you a question, but that's exactly what you want. You want to be thinking about those quantities and those numbers. That's how we gain our experience. And we have a little guest star in our video today. Say hi now. Yay! Say keep working hard, guys. All right, I hope you're well, and I'll talk to you soon.